Okay, yeah, we have covered the first part of chapter 1, which is on basic Fibonacci sequence. So today we're gonna continue the same model in a general form. Okay. Yeah, here these are the web address. So if you go to this web address, then you can easily download those Excel file. So you can use it. So if you have an idea to make to revise this one, then we may open the source to those who like to make some modifications. Okay, and so we have covered this basic model of Fibonacci sequence. Okay, now we start. So we have reviewed the first class. We can improve this model, this spreadsheet. The one first step to do so is adding a scroll bar. So we don't have to type everything. We can just move the numbers bar to make the changes. These are the information that to make those tools in it. And these are the standard techniques that we need to keep in this process. Yeah, you are asked to display and analyze the data using Excel or Sage. The data and graphs and your analysis better be shared in BBS Q&A, and then you may add your comment, or you can revise the ones that you can find in Q&A. And after we make the final version of each of your work related to the math modeling or other information that helps our class, then you will have a chance to give a presentation. And your grade will be based on the quantity and quality of those pieces of the of your work, or the work that you have been involved. You don't have to be the one to give the presentation, but you should get involved in the whole some of those process. You will be asked to submit those work at once in a month as a homework. And these are the technique of dealing with the spreadsheet. Okay, and yeah, this is one example of the regression equation, making a chart and things. Yeah, then this is one example. Now we directly go to the extended model. So here, this is a mathematical modeling with the example of the extended Levitt problem with the lifetime. You have seen it before, but we will go through it once again in detail. Okay, this is the Levitt model, but with the general form of extended Levitt model with the death rate. So here this shows the period, and this is the number of the Levitt pairs, and these are the birth of this from the given Levitt pairs, and as time goes, they're getting old, and they will be died at a certain point. That's the model. So if k is equal to 1 and n is equal to 0, then that's the basic model. But if k moves, then it changes. Then the number, these tables changes, and this gives us this generated the new table, and those data produce this graph like this. If the rabbit dies in an early stage, then the number, this number is increasing, so total number should be decreased in it. Okay. Anyway, here if we, for example, if we make some changes here, instead of 7, if we make 10, then that will make a different model. If you make the copy of these two, then it will make a totally different model. Yeah. Anyway, so here, so my lecture note shows how you make these scroll bars, etc. Anyway, so this extended Fibonacci number model shows if the newborn pair of rabbit dies at a certain period, then the number of living rabbit pairs can be displayed in this table, so you can simulate those. So this table shows, this number shows those informations in it. Okay, and you have seen the graph. Okay, next. Think about the Fibonacci sequence. Here, when period, as you see, this sequence is the Fibonacci sequence. Then think about the ratio between consecutive two terms. Then you will see this ratio converges to a certain number like this. But this can be done by just showing it. Let's see. Let's simulate this ratio. So you don't have any information, but you have a table generated. So you can generate the graph like this. Okay. Here the period 2 Fibonacci numbers, and if you change it, then if you change it, then you will have totally different. If you change it, then you have a different the sequence and different table, different graph as well. But anyway, so as you see, this ratio between two consecutive terms converges to a certain number as n goes to infinity. This is what this table means. What we can think from here, yeah. There are some informations on those numbers here. If you go to this website, then it gives those information, these ratios and these numbers, and what this means in nature, and there are many other informations which is related to this sequence at the elementary level and advanced level or whatever, yeah, and many things. Okay, so you can find more information on this ratio, these numbers. Okay, what is the mathematics inside of this nature, this behavior? Who has the answer? Okay, so in order to find the mathematics inside of this model, so let's think of mathematical model of this sequence. Okay. First, basic Fibonacci sequence can be written in a linear algebra form, in a system of linear equations in this way. As you see here, if you multiply this 2 by 2 matrix on here, then you will see this A1, A2 goes to A2 and A3. And this A3 is the addition of the A1 and A2. So it's A3 is the addition of the earlier previous two terms. If you multiply this matrix to this one, A2, A3, a vector, then it goes to A3 and A4. As you see, this A4 is the A2 plus A3, which is the addition of the previous two terms. It keep going. So we can make this kind of the model, mathematical model, like this. Multiply this matrix, 2 by 2 matrix on a vector, then it generates the second vector, which is related to the Fibonacci sequence. If we write it in this way, then the n plus 1 term, a of n plus 1, can be obtained from the first term, x0, a0, by multiplying the nth power of that matrix. Does it make sense? So, after we got this mathematical model of Fibonacci sequence, we can think of the eigenvalue of this matrix that makes all those relations works. So, you find the characteristic polynomial and solve the characteristic equation to get the eigenvalues, which is this. Here, as you see, A has two eigenvalues. One here, this one, and one is 1 plus the square root of 5 over 2, and the other one is 1 minus square root of 5 over 2, like this. This number is very close to this one. So, this means the largest eigenvalue of this particular matrix is the ratio of the two terms. This shows it. So let's analyze the table. To understand the meaning of it. So this computation shows the graph of Bn, the sequence of Fibonacci sequence. And it converts to a number which is the largest eigenvalue of the matrix A. This matrix. This is a very important form of the matrix. Yeah. This is a special case of the companion matrix that you will see. The largest eigenvalue of A converges to this number, which is this, as n goes to infinity. Okay, this example shows the power of mathematical modeling. Okay, then we can think. Since this has that model is related to the special type of matrix, which is called the Fibonacci matrix. So we can think of the general form of those Fibonacci matrix. We can think of generalized Fibonacci matrix, and also we can think of second largest eigenvalue of the matrix, and also we can generalize it to understand the nature, the essence of nature which you cannot see by your eyes. Okay, so I was able to make a connection to the earlier work of mine, which is related to the Fibonacci sequence and Fibonacci matrix. Okay, so we may continue to think. Let's think of the following generalization of a Fibonacci sequence, like this. if you define a negative terms of the sequence in this way. So as you see, if you define a negative terms of the sequence that we had, then we have 1, 1, 2, 3, 5, 8, 6. But if you define negative terms of the sequence, then that goes to 0, 1, minus 1, 2, minus 3, 5, like this. Addition of those two, the addition of this one and the different sign of this one comes like this. Addition of this one and this one with the negative. So minus 1, minus 2 makes minus 3. Minus 2 plus 3 makes 5. Minus 3 minus 5 makes minus 8, like this. Okay. So if you define it, after you make a table, you see there is a similarity. The only difference is that the alternating terms appeared in here. Okay? Then, take a look on the negative terms of the sequence. Then you find those are the alternating terms of a Fibonacci sequence. The sign changes. Then, let's think about this number, the ratio of the two terms, as n goes to minus infinity. As n goes to minus infinity. Where that goes? This number, if n goes minus infinity, we can simulate it in this way. As you see, there is a sequence. This is a Fibonacci sequence, generalized Fibonacci sequence. As goes to minus terms, it changes 0, minus 1, 1, minus 2, 3, minus 5, 8, minus 13, 21, minus 30. You see, yeah, this. Then we can simulate it in here. Then you will see that the ratio of Cn goes to this, converts to this number. Okay? That number is minus 0.6 like this, which is close to the 1 minus square root of 5 over 2, which is what? That is another eigenvalue of that given matrix, which is the second largest. The very largest one was the 1.6, and the second largest one was 1 minus square root over 2. So we now found that converse. The Cn converts to the second largest eigenvalue of A. Okay? Okay, then now we found the relationship between the second largest eigenvalue of A and the Fibonacci sequence in general form for the negative terms. This shows also a power of mathematical modeling. Okay? And this also shows why you have to know some mathematics. Yeah, you should know how to find the eigenvalues of the matrix to make the connections like this. Okay? In this case, the knowledge that we used in this model was the linear algebra knowledges. Okay? Then we can think the next model like this. This is the English version of the previous page. And think about generalized Fibonacci sequence. Okay, now we think about this kind of the sequence. Instead of 1 and 1, and we have UAN plus VAN minus 1, 2 makes the next term. This is general form. Then, what you can think from here? Okay, so for this generalized Fibonacci sequence, since we have seen a matrix form of the Fibonacci sequence model, so we can easily think of this matrix form. Okay. Then, as you see, A3 can be obtained as UA1 plus VA2, and all others. A4 can be obtained as UA2 plus VA3 like this. Samely, AX1 is equal, if we let XN is AN 2 by 1 vector of an and an plus 1, then we can easily make a relationship ax1 is equal to x2, like this. And also we can continue this process to get this one. So we can easily find the n plus 1 term of that sequence from the basic, with only the knowledge on the matrix A. Okay, now try to find the eigenvalue of the matrix A. Then solve a characteristic polynomial for lambda. Then what we have is this. So this shows we have two eigenvalues of this. V plus minus square root V square plus 4u over 2. So now the largest eigenvalue is this one, and the smallest eigenvalue is V minus square root of V square minus 4u plus 2. Okay. What you can think from here? 자, earlier knowledge, we can easily guess the answer. So this is a general function for the parameter for this model. As you see, this also converges to certain number. As making this table is not difficult at all. It's just the same table with only these parameters. Okay, so we can make all the same thing. So also we can realize it converges to a certain number. Okay, and from that simulation of 2 terms and 3 terms, even here, for the more general form, okay, for U, V, W, like that. So we can easily expand it with the same techniques, same knowledges. So, okay, so we can find it, the ratio also converges a certain number. This shows, and also we can easily guess. We can check our guess was right by seeing those. After we see it, now we have a conjecture. Then we start to prove, to make a paper out of it. So, in order to get the nice theorem, you should have a good view of the real problem, and you should understand the nature first. Simulation of those data are the very easy way to get it. So that's the one importance of mathematical modeling for mathematicians who like to have a nice result. Okay, now you're supposed to solve some of the problems from the textbook in chapter 1, and upload your solutions in Q&A or questions, at least 2 exercise problems in chapter 1, then make comment and revise it, go through it. I will continue to the more general form of the sequences, this for 3 by 3 and etc. And then I will then also we will think about the way of easy way of finding the largest eigenvalue of large size matrix. For 2 by 2 or 3 by 3 matrix, you can easily find the eigenvalues. What about 5 by 5 matrix or 7 by 7 matrix? How you can find the eigenvalues? In order to do so Gelshigoryn circle theorem is the one thing that you can easily guess where the largest eigenvalue is located, but this power method is the one answer to solve it. So actually we use this power method on this Excel to show you how to find the largest eigenvalues. And this power method was introduced a chapter that I uploaded here. So for your case, the wiki has a lot of information on this power method, and YouTube has all the explanation on the YouTube. So you just take a look to go through it. So this shows you we need to know some mathematical knowledge to really understand and to manipulate the mathematical models. Without knowledge, all you have is just the data. that doesn't tell much. So in order to explain, to understand, you should have the mathematical knowledge. So maybe some of you may study and then upload your note. Then after revision, I will give you the chance to explain what it is. Yeah. Okay, and Gershgorinta theorem, etc. I think time's up, so I will finish today's class here. Any questions?